Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great tool for you to practice your entrance exam question papers as well as CBSE Class 12 mathematics papers and other subjects papers as well. You must download our app for a better approach to the study material. So, students will be starting with the CBSE Class 12 Mathematics 2022 Term 2 All India Set 1 paper. About 14 questions will be there in this video. So we'll be starting the section A, which is containing 2 marks questions. Let's go. A very best of luck. Question number 1. So you have to find the integral of dx upon x squared minus 6x plus 13. This, let's say this is equal to I. So this I can be written as integral of dx upon x squared minus 6x plus 13 plus minus 9. So that is dx upon x square. Okay. See, this can be written fine. This is x square minus 6x plus 9 plus 13 minus 9. This is equal to 4. So this is integral dx x minus 3 square plus 2 square. Fine. Now this is the integral. This is given by half of tangent inverse of x minus 3 upon 2 plus c. This is the answer to the question. Hope you have understood that well. Next is question number 2. You have to find a general solution of this differential equation. E raised to power dy by dx is equal to x square. So this is see, I'm taking log on both sides. So log of e raised to power dy by dx is equal to log of x square. I'm taking log on both sides. So this becomes dy by dx, and this is equal to, this can be written as 2 log of x, or dy is equal to 2 log x dx. Integrating both sides, you have y is equal to 2 log x into x minus integral of 1 by x into x dx. I have used integrating by parts over here. So this is equal to, fine, this is x. This is 2 into x into log x minus, this is integral of 1, that's equal to x plus c. Okay, so I'll take x also common. Log x minus 1 plus c. This is the answer to the question. Hope you have understood that. So let's move to the next question. We have found a general solution of this differential equation. Next is question number 3. Write a projection of the vector b plus c on the vector a, where a is equal to this, b is equal to this, and c is equal to this. Okay, so you have b plus c. This is equal to I plus 2j minus 2k plus 2I minus j plus 4k. So this is equal to 3I plus j plus 2k. Now projection of on a vector is equal to b plus c, and a vector's dot product, which is equal to 8. This, the dot product of them divided by the magnitude of it, right? Hope you are clear with this. This was a unit vector, not the a vector itself. Okay. So this is equal to, what was b plus c vector? This was 3i plus j plus 2k. The dot product with a vector was equal to 2i minus 2j plus k divided by the magnitude of a vector, which is given by the root of 2 square 4 minus 2 square 4 plus 1 square 1. This is equal to 3 into 2, 6 plus 1 into minus 2, which is equal to minus 2 plus 2 into 1, that is equal to 1 root of 9. This gives you 6 upon 3 or 2. This is the answer to the question. Hope you have understood that. Next is question number 4. If the distance of point 111 from the plane this is 5 upon root of 3, you have to find out the value of lambda. Okay. Question number 5. 2 cards are drawn successfully with replacement from a well-shuffled pack of 52 cards. Find the probability distribution of the number of the spade cards. Okay, so here the sample space, 2 cards are drawn successfully with the replacement from a well-shuffled pack of 52 cards. So you have to find the probability distribution. Question number 4, it says if the distance of the point 111 from this plane is 5 upon root 3, you have to find out the value of lambda. Reduce the equation this is. So distance of point 111 from x minus y plus z plus lambda is equal to 0 is given by, this will be 1 minus 1 plus 1 plus lambda whole divided by root of 1 square plus 1 square plus 1 square. This is equal to 1 plus lambda upon root 3. Okay. Now you're given that this is equal to 5 upon root 3. So according to the question, 1 plus lambda upon root 3 is equal to this, right? And these two will cancel. You will have 1 plus lambda is equal to 5 or lambda is equal to 4, right? See, one thing there, see, when you will remove this modular sign, this can be plus minus 5, right? So if you are taking the value of this as plus 5, 1 plus lambda, if you are taking as 5, here the lambda will be equal to 4. And if you are taking the value of lambda is minus 5, here the lambda will equal to minus 6. Okay. So these are the two possible values for this question. That is 4 and minus 6. That's it. Hope you are clear with this. Let's move to the next question. Question number 5. 2 cards are drawn successfully with the replacement from a well-shuffled pack of 52 cards. You have to find the probability distribution of the number of spade cards. If we talk about this sample space of this problem, sample space will be given by either the 2 cards are both are spade. First one is non-spade and the second one is spade. The first one is spade and the second one is non-spade, or both are non-spade cards. Okay. If I say N denotes number of spade cards, then then in this case, number of spade and spade cards, here the number of spade cards is equal to 2. In this case, number of spade cards is equal to 1. In this case, number of spade card is equal to 1. And in this case, number of spade cards is equal to 0. Right? And okay, fine. Next, you know the probability of getting the spade cards is equal to 13 upon 52. Because there are 13 spade cards out of the 52 cards, and that is equal to 1 by 4. So the number of probability of getting the non-spade cards will be given by 1 minus 1 by 4, which is equal to 3 by 4. Now let's make the probability distribution table. Here you have X and PX. So probability that no spade card is there, 1 spade card is there, or 2 spade cards is there. So this probability that of having the 0 spade cards, see, this is the one which is having the 0 spade cards. This will be given by 3 by 4 for the first one. It's calculated here only. So this will be 3 by 4 for the first case and 3 by 4 for the second case. That is a total of 9 by 16. 1 spade card will be given by, see, here are the two chances. In both the cases, there is only 1 spade card. So 2 into 3 by 4 into 3 by 4, which is equal to 16 by 6 by 16 or 3 upon 8. And Yeah, for both the spade cards. Both the spade cards in this scenario, this is given by both the spade cards. That's 1/4 into 1/4, which is 1/16. So this is the required probability distribution table. Hope you have understood that. Let's move to the next question, number 6. A pair of dice is thrown and the sum of numbers appearing on the dice is appeared to be 7. You have to find the probability that the number 5 has appeared at least on at least one die. Or there is a choice. So you are given a choice between these two questions. You can attempt any one of these. So we will be solving both the questions and it's up to you, whichever you find it easy. Okay. So let F be defined as the event in which sum of number on die is equal to 7. So what is the sample space for F? What are the probable values on both the die? If first die is having 1, the other one will have 6. If the first one is having 2, this will have 5, 3, 4, 4, 3, 5, 2, 6, 1. Now let E be the event that 5 has appeared at least on at least one die. So this is, see what is the sample space in this case? 5, 1, 5, 2, 3, 4, 5, and 6. Then it may have 6, 5, 4, 5, 3, 5, 2, and 1. So this is the possible sample space for 5 has appeared at least once on one die. Okay. Now you have to find that the sum should be 7. Also, 5 should appear on one die. So you have to find out the probability that both the events occur together, that is PE intersection F. According to the sample space, this is possible only in case of 2, 5 and 5, 2. Okay. You have to find the probability that the number 5 has appeared at least one die. Okay, so probability that event has occurred when F event has occurred. This is given by probability E intersection F divided by probability of F. This is the number of E on F, which is equal to 2 divided by the number of F, which is equal to 1, 2, 3, 4, 5, 6. That is equal to 1/3. So this is the probability, required probability, which we were looking for in the answer. Now there is a choice in this question. The probability that A hits the target is 1/3 and the probability that B hits the target is 2/5. If both try to hit the target independently, find the probability that the target is hit. Okay, let's start from here. Here's the B section. Now let PA be the probability that A hits the target. Now this, see in this question, according to that, it is given as 1/3. Now PB, probability that B hits the target, that is given by, I think, 2/5. Now probability that target is not hit, this is given by 2/3. See over here, probability that A doesn't hit the target. A, probability A does not hit is 1 minus 1/3, that is equal to 2/3. And the probability B does not hit is 1 minus 2/5, which is equal to 3/5. So this is equal to 2/3 into 3/5, which is 2/5. Okay. Therefore, the probability target is hit is 1 minus probability target is not hit, 1 minus 2 by 5, which is 3 by 5. Right. So this is the answer to the question. Probability that the target is hit is 3 by 5. Hope you have got that. Let's move to the next question, number 7. You have to, this is a 3 marks question. Now you have to evaluate this particular integral. Let's go for that. Let's say this is equal to I. So you are given I is equal to limits 0 to 2 pi dx upon 1 plus e raised to power sine x. Okay, fine. Now I'll be using one formula, and that is, let's write integral limit 0 to a fx dx. We have used that multiple times in our questions, f of a minus x dx. So using this formula, now I can be written as integral dx 1 plus e raised to power sine 2 pi minus x, which is equal to dx 1 plus e raised to power minus sine x, which is equal to 0 to 2 pi limits. That is equal to dx upon 1 plus e raised to power 1 plus 1 upon e raised to power sine x. So this is integral 0 to 2 pi dx upon e raised to power sine x plus 1 into e raised to power sine x. I hope you got till here. All right. Now, let's say this is equation 2 and this one is equation 1. Adding 1 and 2. So you have 2I is 0 to 2 pi 1 upon 1 plus e raised to power sine x plus e raised to power sine x upon 1 plus e raised to power sine x dx. 0 to 2 pi 1 plus e raised to power sine x upon 1 plus e raised to power sine x dx. You have integral 1 into dx 0 to 2 pi. This is 2I is equal to x 0 to 2 pi. 2I is 2 pi minus 0, which gives you the integral is equal to pi. Okay, so answer to this question is equal to pi. Hope you have got that, understood that. Next is question number 8. Find the particular solution of the differential equation this given y of 1 is equal to 0. Okay. So I'm going to solve the A part. This is a choice question. X into dy by dx is minus y is x square into e raised to power x. And okay, let's divide both the sides by x. Both sides by x, you have dy by dx minus y upon x is equal to x square into e raised to power x upon x. Now here the integrating, this is of the form dy by dx plus px into dy by dx plus px into y is equal to q of x. Right, so here px is equal to minus 1 by x and qx is equal to x square, or this is equal to x into e raised to power x, because these two will cancel. Okay, now integrating factor is px. So integrating factor is given by e raised to power integral of minus 1 upon x into dx. This is equal to e raised to power minus 1 into log of x, or this is equal to e raised to power log of x raised to power minus 1, which simply means this is equal to x raised to power minus 1 or 1 by x, right? Therefore, y into 1 by x, this is equal to x into e raised to power x multiplied by 1 plus x upon 1 upon x upon this. These two will cancel out and you will have y upon x is equal to integral e raised to power x dx, or y upon x is equal to this. Okay. Now you're given that if in this question you're given y of 1 is equal to 0. Y of 1 is equal to 0. So that means if x is equal to 1, y is equal to 0. So let's put that. If I'm putting x is equal to 1, 0 upon 1 is equal to e raised to power 1 plus c, which gives you e is plus c is equal to 0, or c is equal to minus e. Right? Now the equation becomes, if see, this was your equation. Say this is 1. From 1, you have y is equal to x into e raised to power x minus x into e raised to power 1. Or this is the answer to the question, right? So here, that's it. I hope you have understood that well. Now let's move to the B part, B option of this question. We have to find the general solution of this differential equation. Let's go for that. So here we write down B part. So given differential equation is x into dy by dx is equal to y log y minus log of x plus 1. Here you have dy by dx is y upon x. This can be written as y upon x plus 1. If I put y is equal to v into x, you have dy by dx is equal to v plus x into dv by dx, or y plus x into dv by dx is equal to, see, if I find the derivative dy by dx, this is equal to first function into derivative of second plus second function into derivative of first. So this now can be written over here. This is equal to v plus x into, sorry, this was already done. I'll redo these steps. This will not, sorry, this we have already done. Now the B part of this question is you have to find the general solution of the differential equation. This. So here we have the B part. Let's write on the equation x into dy by dx is equal to y into log y minus log x plus 1. You can write it as dx into dy by dx is equal to, I'll take this x over here. This is log y upon x plus 1. I'll put y is equal to vx. Or from here you have two things. First of all, if I find the derivative, this is first function to derivative of second plus second function into derivative of first. Also, you have y by x is equal to v. Okay. So now you have y upon x is equal to v. Fine. So this can be written as v plus x into dv by dx is equal to dy by dx, right? And if I look from this equation 1, right, let's solve this equation a bit. You have dy by dx is equal to y upon x log of y upon x plus 1. Y upon x was equal to v, so this is v into log of v plus 1. Now let's fill this thing over here. You have v plus x into dv by dx is equal to v into log of v plus 1, right? Or you will have this as x into dv by dx is equal to v into log v, right? I hope you are clear till here. So dv upon v log v is equal to 1 upon x into dx. Let's do the integration on both the sides. I hope you are clear till here. So when you have integrated that, this will be log v is equal to log of x plus log of c. So log v is equal to, here c and x will be multiplied, or you have log v is equal to cx, or what was v equal to? V was equal to y upon x. See from here. So y upon x is equal to cx. This is the answer to the question. Hope you have understood that. Let's move to the next question, number 9. Two adjacent, again, you have a choice in this question. Two adjacent sides of the parallelogram are represented by these two vectors. You have to find a unit vector parallel to one of its diagonals, also the area of the parallelogram. Okay. So adjacent sides of the parallelogram are given as that. Let's say this is A. A is 2i minus 4j plus 5k, and B vector is I minus 2j minus 3k. We know that the diagonal of the parallelogram is given by A plus B. Diagonal of the parallelogram is given by A plus B. So A plus B will be equal to, like, summation of these two factors. This will be 3i minus 6j plus 2k. Hope you are clear with this. Now the unit vector parallel to the diagonal, unit vector parallel to the diagonal is given by A vector plus B vector divided by the modulus magnitude of them. This is 3i minus 6j plus 2k divided by the root of 3 square minus 6 square plus 2 square, which is equal to 3i minus 6j plus 2k, which is 936 and 4, that is root of 49, which is 7. Okay. So this is equal to 3i minus 6j 2k upon 7, or 3 by 7i minus 6 by 7j 2 by 7k. So the area of, now you have to find out, what you had to find out in the question was area of the parallelogram also. Okay. We found the unit vector parallel to one of the diagonals. Now we have to find out the area of the parallelogram also. So this is one of your answers. And area of the parallelogram is given by the cross product of A and B, which is I, J, and K. So this is 2 minus 4 and 5, 1 minus 2 and minus 3, 12 plus 10 minus 6 plus 5, minus 4 plus 4, which is equal to 22i, 11j, and 0k, which is, I'll take the 11 common. So 2i plus j. Magnitude of A and B vector, the cross product of A and B vector, this is equal to 11 root of 2 square, 1 square, which is 11 root of 5 square units. Hope you have got that. Let's move to the B part, or the optional part of this question. A is given by this vector, B is this, C is this, are such that the vector this is perpendicular to the vector C. You have to find out the value of lambda. Okay, this is a pretty easy question actually. Let's go for that. Here we go. So question number B part, here you are given that A plus lambda B vector is perpendicular to C vector. If they are perpendicular, that means their dot product is 0, right? Or A dot C vector lambda B vector dot C vector is equal to 0. What was A vector? 2i 2j 3k dot product with 3i plus j plus lambda minus I 2j k 3i plus j is equal to 0. This will be equal to 3 into 2, 6 plus 1 into 2, 2 plus 0 lambda minus 3 plus 2 0 is equal to 0. 8 minus lambda is equal to 0 or lambda is equal to 8. So lambda is equal to 8. This is the answer to the question B part. Hope you have got that. Next is question number 10. You have to show that this and these two equations, they are coplanar ones. Question number 10, show that the lines 1 minus x upon 2 is equal to y minus 3 upon 4 is equal to z upon minus 1. And this line, they are coplanar. That is, these both lines, they are lying in the same plane. Let's rearrange this one. This can be written as, this line can be written as x minus 1 upon minus 2. This is equal to y minus 3 upon 4 is equal to z upon minus 1. And the second line, x minus 4 upon 3. Now this one, I'll take the 2 outside. So y minus 1 upon minus 4. So this 2 and this 4 will cancel. This will be y minus 1 upon minus 2. Hope you got that. Is equal to z minus 1 upon 1. Right. Now, if the lines are coplanar, the general lines are coplanar, then the general matrix form is x2 minus x1, y2 minus y1, z2 minus z1 upon a1, b, not upon, sorry. Here is a1, b1, c1, a2, b2, c2. Okay. Where this is a1, b1, c1, this is a2, b2, and c2. Correct. Let's go for that. The next one, x2 minus x1. This can be this minus this. Now it will be 3. Then y minus 3 minus y minus 1. This will give you minus 2. Similarly, it will give you 1. And here the coefficient, sorry, not the coefficient. This is minus 2, 4, and minus 1. Minus 2, 4, and minus 1. And the last row will be 3, minus 2, and 1. Right. See, this should be equal to 0. Okay. Now let's solve what will come out to be the determinant for this matrix. This will be 3, 4, minus 2 plus 2, 2, minus 2 plus 3 plus 1, 4 minus 12. There is 6 plus 2 minus 8. And this is equal to 0, which proves that these two lines, they are coplanar. Right? Hence proved. Hope you understood that. Let's move to the next question. Question number 11, find the area of the region bounded by the curve 4x square is equal to y or y is equal to 4x square and the line y is equal to 8x plus 12 using integration. So definitely let's draw them on the graph first. So y is, let's make the table for the line y is equal to 8x plus 12. Okay, so here we go with the x and y. If I'm putting x is equal to 0, y is 12, x is equal to 1, y will be 20. If x is equal to minus 1, then y will be 4. Okay, let's plot it now. So if x is minus 1, y will be 4. Okay, so this point has got to be here somewhere. X is 0, y is 12. About here. X is 1, y will be 20. So this has got to be the slide somewhat. All right. This was minus 1. Now the curve is 4, y is equal to 4x square. So this curve is a parabola. This one. Okay. So ultimately, I'll redraw this because this is a short space. This will be something like this. Okay. So they will meet at a point. You have to find out this area of the shaded region. Okay. Fine. Let's find out the point of intersection first. This is the line y is equal to 4x square, and this is the curve y is equal to 4x square, and this is the line y is equal to 8x plus 12. Okay. Fine. Let's find out the point of intersection now. Y is equal to 8x plus 12. So let's equate them. You have 4x square. Divide both the sides by 4. You will have 8 x square minus 2x plus 3, not plus, minus 3, is equal to 0. So the two factors will be, I think, x square minus 3x plus x minus 3 is equal to 0. So x minus 3, x plus 1 is equal to 0, which makes the two possible values for x, that it is either this is the point of intersection, right? These are the 2 point of intersection. X is equal to 3 and minus 1. So this point, for this point, x is equal to 3, and for this point, x is equal to minus 1. So when x is equal to 3, the value of y will be, if I look at this one, when x is equal to 3, so 9 fours are 36. And when x is equal to minus 1, this is 4. Hope you got that. So these are the 2 points of intersection for this, these two, with this line and the curve. Correct. Now you have to find out the area, this area. All right, let's go. So we have to use integration. Required area is given by minus 1 to 3, because we are moving from minus 1 to 3. The area which is covered by the line minus the area which is covered by the curve. Right. So this area is covered by the line, and I have to subtract the area which is covered by the curve. Dx. Right. So this is limit minus 1 to 3. This will be, I'll take the 4 outside. Fine. So this will become 2x plus 3 minus x square. Okay, simple as that, dx. Okay, so now let's integrate. You have the simple terms. This is 4. Now this is 2x square upon 2. Limits minus 1 to 3 plus 3x limit minus 1 to 3 minus x cube upon 3 limits minus 1 to 3. That's it. So 4, this has got to be 2 into 9. That's 18. This will cancel. Okay, leave it. So this is 9 minus 1 plus 3 into 3 plus 1 minus minus 1 plus will be plus 1 minus 3 cube upon 3 minus 1 upon 3, minus of minus 1 upon 3. So this is equal to 8 plus 12, and this will cancel 3. So this is 9 plus 1 by 3. Yeah. This is 9 plus 1 by 3. And that's going to give you 4 into 20 minus, this is 28 upon 3, 4 upon 3 into 60 minus 28, 4 upon 3, that's 32, right? Okay, so this is 128 upon 3. This is square units. This is the answer to the question. This is the required area of this region, which is bounded by the shaded portion. 123 by 8 square units. This is the correct answer to the problem. Hope you have got that. Let's move to the next question, number 12. You have a choice in this question. Both are integration problems. Let's go with the first part. Okay, so this is A. Let's start with A. Let's say this is equal to I. The I is given by integration of x square upon x square plus 1 into 3x square plus 4 dx. Now I'll put this t, x square is equal to t. Then let's, if I find out the derivative, dt is equal to 2x into dx. Okay, so this integration will become integration of t upon t plus 1 into 3t plus 1. One thing I will do, I will keep the dx as dx only. Okay, I will not touch it. So next, this fine. Now I'll be using this t upon t plus 1 into 3t plus 1 in this is equal to, this can be written as a upon t1 partial uh, fractions 3t plus 4. So t is equal to, I'm taking the LCM and then cancelling the denominators. Anyways, let's solve it properly. T plus 1, 3t plus 1, that's equal to t plus 1, 3t plus 1, a into 3t plus 1, b into t plus 1. The denominators will cancel and you will have t is equal to a into 3t plus 1, b into t plus 1. At t is equal to minus 1, what we get is minus 1 is equal to a is to minus 3 plus 4 plus 0, or a will be equal to minus 1 upon 1, that's equal to 1. And at t is equal to minus 4 by 3, what we get is minus 4 by 3 is equal to a into minus 4 by 3 into 3 plus 4 plus b into minus 4 by 3 plus 1. That's minus 4 by 3. This will cancel and this will be 0. A into 0 plus b into minus 1 by 3. Or you will have 4 by 3 is equal to b by 3, or b will be equal to 4. Now let's get back to our integration problem. The I that was equal to, see, this we had split up already as this. Okay, from 1. So that whole thing, now it can be written as a, which is minus 1 upon x square plus 1 plus 4 upon 3x square plus 4. This whole into dx. There was, see, now you got to know why there was no need to touch the dx thing. Okay. So, okay, that's there. Okay, fine. No limits were given. Fine. So now this is equal to, let's split it up. This is minus integration of 1 upon x square plus 1 dx plus, I'll take the 4 outside, and this will be 4 and 3 outside because I want to make the coefficient of x square as 1. 1 upon x square upon, okay, x square, that's it, upon 1. No need to write that. Fine. Plus 4 by 3, that's it, dx. So this is the integral of this is equal to tangent inverse x plus 4 by 3. Now this can be written as 1 upon x square plus 2 upon root 3 whole square dx. So this is tangent inverse x plus 4 by 3 into root 3 by 2. That is tangent inverse of root 3x upon 2 plus c. Or that is equal to 2 upon root 3 tangent inverse 3 root 3x. Now this is not under the whole weight. So this is 2 root 3 tangent inverse root 3 upon 2x minus tangent inverse of x plus c. Okay, there was the minus sign over here. So this is the answer to the first part, or you can say the first question, which is another option for this question. Hope you have got that. Let's move to the B part now. So this is the B question, this is the A question. Now again, an integral problem. In this case, we are given the limits -2 to 1 root of 5 minus 4x minus x square. This is actually a pretty easy question in comparison to the previous one. Let's go. So you have to find out the integral of -2 to 1 root of 5 minus 4x minus x square dx. This is -2 to 1 integration. I'll take the minus common outside, x square plus 4x minus 5 dx. So let's make it a perfect square. -2 to 1 integration, and here I'll have x square plus 4x plus minus 4. So I can write that as 2 square, right? To understand that easily, dx. Okay, I hope you got till here. So this is -2 to 1 integration of, this will be x plus 2. I'll use x plus 2 whole square minus 4 minus 5 will give me -9 into dx. Hope you got that, right? This was for the whole. Now this will be -2 to 1, 9 minus x plus 2 whole square dx, that is equal to integral -2 to 1 root of 3 square minus x plus 2 square dx. Now, this is of the form root of a square minus x square. You have to find the integral. So you know what the integral is. This is given by x plus 2 upon 2 root of 3 square minus x plus 2 square plus 9 by, or 3 square by 2. That's better to write. 3 square by 2 sine inverse x by 2 plus 3 upon x plus 2 upon 3, limits -2 to 1. Let's write down the formula over here once. So this integral, the formula is given by x by 2 root of a square minus x square plus a square upon 2 sine inverse x upon a plus c. Hope you understood this formula. So using this formula, we got this particular equation, right? Now let's just, the thing is we have to put in the limits. Let's go for that. So when you put x is equal to 1, yeah, this is 1. So when you put x is equal to 1, this will be 3 by 2 root of 9 minus 3 square. Actually, this will be 0. Fine. Plus 9 by 2 sine inverse 3 by 3. Okay. Minus. Now, this will be 0 again because -2 plus 2, this will be giving me 0. Plus 9 by 2 sine inverse of 0 again. Okay. Fine. So this is equal to, this will be 0 plus 9 by 2 sine inverse 1. Sine inverse 1 is the value for pi by 2 plus minus 0 minus 9 by 2. Sine inverse 0 is for 0. So this is equal to 9 pi by 4. This is the answer to the second part. Second option of the question, 9 pi by 2. Hope you got that. 9 pi by 4. So this is the answer to the B part of the question. Hope you got that. Next is question number 13. Find the distance of the point 1 minus 2, 9 from the point of intersection of this line and this plane. So you have to find the distance of this point from the point of intersection of this line and this plane. Hope you have got the criteria, what you need to find out, right? Let's start with the question. Given line is R is equal to 4i plus 2j plus 7k plus lambda 3i 4 j plus 2k. Any point on this given line, any point on this line is given by C 4 plus 3 lambda, comma 2 plus 4 lambda, 7 plus 2 lambda. Any point on this given line is given by this. Now this point, for finding the point of intersection of this line and this plane, this point will match with this plane. Now, if it will match with this plane. Let's write the equation of the plane first. The plane is given by r dot I j I minus j plus k is equal to 10. So that is that means 4 plus 3 lambda minus 2 minus 4 lambda plus 7 plus 2 lambda is equal to 10, which gives you this is minus lambda. This will be lambda plus solving these three will give you lambda and 2 9. This will be lambda plus 9 is equal to 10 or lambda is equal to 1. Right. Now let's find out the point of intersection because this was taken as the point of intersection. So point of intersection. See, point of intersection where this line and the plane, they are meeting each other. I fill the coordinates of general coordinates of any of this line on this plane to get the value of lambda. Okay. And this was already taken as the point of intersection. So the point of intersection will be 4 plus 3 into 1, 2 plus 4 into 1, 7 plus 2 into 1. Hope you got that. And this point of intersection will be 7, 6, and 9. This is the point of intersection. Now you have to find out the distance of this point 1 minus 2, comma 9 from this point. Required distance is equal to, required distance is distance between 7, 6, 9 and 1 minus 2, 9. So this distance is given by d is equal to root of 7 minus 1 square plus 6 minus of minus 2 plus 2 square, 9 minus 9 square. This is equal to 6 square 36, 8 square 64, which is root of 100, and the answer is equal to 10. So 10 units is the distance between these points. Okay, 10 units is the distance between this point and the intersection of this line and this plane. Hope you have understood that. Let's move to the next question, number 14, which is going to be the last question for this set. Now, this is a case study. Always this is last question represents your case study. It says the shopkeeper sells 3 type of flower seeds, A1, A2, A3. They are sold in the form of a mixture where the proportions of the seeds are 4:4:2 respectively. The germination rates of the 3 types of seeds are 45%, 60%, 35% respectively. So based on this information, you have to calculate the probability that a randomly chosen seed will germinate. All right. So first thing, I'll take 3 events, E1, E2, and E3. So E1 is the event that the seed chosen is of type A1, A2, A3, right? And A germinates. A is the event in which the seed germinates. Okay. Now it's given that the probability germination rate of the 3 type of seeds are 45%, this and this. All right. First thing, wait. Here it is given. The proportion of these seeds are this, this, and this. Therefore, the probability that type A seed will be chosen, that is the probability of event E1 to happen. This is 4/4 plus 4 plus 2, which is equal to 4/10. Probability E2, that is the A2 type seed will be chosen. This is again the same 4/10. E3, see, this is what why I'm writing is because of this ratio. Okay, this ratio. So E3, this is equal to 2/10. Correct. Now the probability of A upon E1 is equal to, it's given that the germination rates is 45, 60, and 35%. So probability that the seed germinates of E1 type, A1 type is 45%. Probability that the seed germinates of A2 type is that was 60%. And the probability that the seed germinates is of A3 types, this is 35%. Hope you got till here, right? This is what you needed to find out, the probability that a randomly chosen seed will germinate is given by these three probabilities. This is the answer to the first part. Let's go with the B part now. Calculate the probability that the seed is of type A2 given that a randomly chosen seed germinates. Okay. So, wait, what we needed? Probability that the seed is of type A2 given that the randomly chosen seed germinates. Fine. So, required probability is given by probability that E1 into this probability seed germinates of A2 type into this probability E3 into this, right? So this is it. This was equal to 4 upon 10 into 45 upon 100, 4 upon 10, 60 upon 100, 2 upon 10, 35 upon 100. So that is equal to, see, the LCM will be 1000 only for each of them. So I'll take the, directly I'm calculating the LCM. This is 180, 240, 70, which is equal to 490 upon 1000. That is equal to 49 upon 100. Okay. Question number 14. This is the last question for this set of the paper. This is a case study. Always, mostly you are having the last question as a case study. It says a shopkeeper sells 3 types of flowers, A1, A2, A3. They are sold in the form of mixture where the proportion of these seeds are 4:4:4 respectively. Okay. First thing, before going on with the next thing, first thing I'll talk about till here. So we are having 3 types of flower seeds, A1, A2, A3. They are sold in the mixture, in the form of a mixture. So the proportions are of A1 is 4 to 4 is to, sorry, A1 is 4, A2 is 4, and A3 is 2. So this is the proportion of the mixture of the seeds, right? Let 3 events, E1, E2, and E3. E1 be the event that the seed which is chosen is of A1 type. E2 says that the seed is A2 type. And this says that seed is of A3 type. Okay. Now, according to this, the probability of withdrawing A1 type seed is given by 4 upon 4 plus 4 plus 2. That is equal to 10. E2 event is again 4 by 10. E3 event is 2 by 10. Hope you got that, right? Next, it says the germination rate of the 3 seeds are 45%, 60%, and 35% respectively. So, I'm not solving anything. I'm not getting to A and B parts. I'm just discussing. I'm just analyzing what is given in the question and writing them in the formula form. Okay, so according to this, probability that the seed is germinating, if I'm taking the A as seed germinates. So if I'm taking A as the seed germinates, probability that the seed has germinated and the seed is of A1 type is 45%. Probability that the seed has germinated of A2 type is 60%. Probability that the seed has germinated is of A3 type is 35%. Okay, 35%. Now, first question, first part, calculate the probability that the randomly chosen seed will germinate. So this is the A part. It says probability that the seed will germinate will be either, see, it will germinate either A1 type, either A or A2 type or A3 type. So this is given by probability that A1 type seed will be chosen multiplied by probability it will germinate, plus probability A2 type seed will be chosen multiplied by probability A2 type seed will germinate, plus probability A3 type seed will be chosen multiplied by the probability that that seed will germinate. Hope you got this thing. So this is equal to 4 upon 10 into 45 upon 100, 4 upon 10 into 60 upon 100, 2 upon 10 into that was 35 upon 100. Correct? So all are having 1000 in the denominator. So I'll directly take the LCM as 1000. This is 180. This is 240. And this is 70. A total of 490 upon 1000 or 49%. That's it. This is the answer to the A part. The probability that this randomly chosen seed will germinate is 49%. Okay. Or 49 upon 100, whatever you would like to. Fine. Next, the B part. B part says you have to calculate the probability that the seed is of A2 type given that the randomly chosen seed germinates. So you want to say that A2 type seed germinates. Okay, this is given by probability E2 event will happen and that A2 type seed will be chosen and it will germinate. Correct. So this is given by probability E2 multiplied by probability A upon E2 divided by the probability that the seed will germinate. Okay. Now that is equal to 4 upon 10 into 60 upon 100 and the probability seed will germinate. We just calculated that in the last question. It was equal to 49 upon 100. Okay. So this 100 and this 100 will cancel. This will cancel with this. You have 24 upon 49 as the answer to the B part. Hope you have understood that well. So students, with this, we have completed all 14 questions which were having some choice for the CBSE Class 12 Mathematics 2022 Term 2 All India Set 1 paper. So hope all these questions were clear to you, and don't forget to visit our website www.examsnet.com to practice your Class 12 question papers and many more entrance exam question papers. You must download our app. The link is available in the description box. A very best of luck for your exams. Keep shining, keep rising high. That's all for this one. Bye. Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great tool for you to practice for your class 12 mathematics question papers as well as your other entrance exam question papers. Students, you must download our app. The link is available in the description box for a better preparation for your exams. And today, students will be solving the CBSE Class 12 Mathematics, CBSE Class 12 Maths Term 2 2022 All India Set 2 paper. This paper will be having of certain questions, but you'll be solving, except these, all other questions will be from your set, are from the set 1. So do visit our video of the set 1 papers questions as well. Okay, so let's start with today's paper. I'll be solving the very first question, which is carrying 2 marks from the section A. Let's go. Best of luck. So it says you have to find the general solution of this equation. Log dy by dx is equal to ax plus by. Let's write it down. You have log dy by dx is equal to ax plus by. I'll be using a property. Log x to the base a is equal to y can be written as a raised to power y is equal to x. Okay. So now this equation is dy by dx is equal to I can write it like this, e raised to power ax plus by, right? Correct. So by the separable proper variable, by separating the variables, you have dy by dx is equal to e raised to power ax into e raised to power by. Now I'll segregate the terms with the y and the x. So this is 1 upon e raised to power by dy is equal to e raised to power ax into dx. Now integrating on both the sides, what you will get is this can be written as e raised to power minus by into dy is equal to integral of e raised to power ax into dx. So this will be e raised to power minus by upon minus b is equal to e raised to power ax upon a plus c. Correct. So I hope you're clear till here. Now let's take everything on one side. So this will be e raised to power ax upon a, e raised to power minus by upon b plus c is equal to 0. Hope you understood this, and this is the answer to the question. Right? Next is question number 2. Now this is section B question. That means it's having 3 marks. It's a vector problem. Choice is given in this question. It says if A, B, C are 3 vectors such that the dot product of them, A and B, is equal to the dot product of A and C, and the cross product of A and B is equal to the cross product of A and C. A is not equal to 0. You have to show that B vector is equal to C vector. Or you have a choice with this question, but I'll start with the first question. We'll be solving both the questions one by one. So let's start with the first one. You are given that the dot product of A and B is equal to the dot product of A and C. Similarly, the cross product of A and B is equal to the cross product of A and C. So now what you have to show is this. Let's write to prove B vector is equal to C vector. Okay, so now you have two conditions in this case. First, see, A dot B vector minus A dot C vector is equal to 0. I'll take the A common. So dot product with B minus C vector is equal to 0, which means that B minus C vector is equal to 0 because you are given over here that A vector is not equal to 0. Correct? Okay. So if this is 0, then simply means B vector is equal to C vector, hence proved, right? Also, one more thing, if the dot product of these two vectors is equal to 0, this means one more thing. What is that? If the dot product of two vectors, if dot product of two vectors is equal to 0, then they are perpendicular to each other. Correct? Which simply means A is perpendicular to B minus C vector. Okay. Now let's go with the condition 2. You are also given that the cross product of A and B, condition 2, cross product of A and B is equal to cross product of A and C. Let's take them like this. This is equal to 0. So you can write it like A cross B minus C vector is equal to 0, which simply again means B minus C vector is equal to 0 because A is not 0. You are given in the question. This thing is given in the question itself. So, sorry, B vector is equal to C vector. This is proved. Now, one more thing. See, if the cross product of two vectors is 0, that means if cross product of two vectors is 0, therefore angle between them is 0 degree, right? So see, what do you mean by E cross B? This is given by multiply magnitude of B vector and this sine of angle between them, right? So if it is equal to 0, that means this is 0, theta is equal to 0, or these vectors are parallel. That means A vector is parallel to B minus C vector. Okay. Now, from these both things, if I say this as 2 and this one as 1, see, from 1 and 2, A cannot be both perpendicular and parallel to BC. From here, you are getting that A is perpendicular to BC, and from here, you are getting that A vector is parallel to BC. Correct? These are not true. This is not true. That means only the possible thing is that B and C, they are equal, because this thing, they contradict each other. Only what the thing that prevails in both the cases is B is equal to C. See this one. Okay. Therefore, for sure, B vector is equal to C vector. That's it. And the angle between them, this is not equal. Okay. Angle between A and B minus C is not equal. And B is equal to C from 1 and 2. Hope you got that. Let's move to the second option. Second option is again vector. Magnitude of A vector is 3, B vector is 5, C vector is 4, A plus B plus C is equal to 0. Then you have to find out the value of A dot B plus B dot C plus C dot A vector. Okay. So let's go on solving this. Here we go with the B part. You are given A plus B plus C vector is equal to 0. That means this is square is also equal to 0, correct? Which can be written as A vector plus B plus C dot A plus B plus C is equal to 0. See, one thing I'm using over here, I'll not wait. So if there are two vectors, the dot product of two vectors is equal to, here is x supposed to be, the square of magnitude between them, okay, of that. So this is equal to, we came over here, I have used the same property. Now this becomes magnitude of A square plus magnitude of B square plus magnitude of C square plus 2 into A dot B, B dot C, C dot A is equal to 0. And you are given this, that the magnitude of A is equal to 3. So 3 square, 5 square, and 4 square plus 2 into A dot B, B dot C, C dot A is equal to 0. This is 9 plus 25. That's 34. 34 and 16. That's 50. So twice of A dot B, B dot C, C dot A is equal to minus 50. And if I'll take 2 on this side, so A dot B plus B dot C, C dot A is equal to minus 25. And this is the answer to the question, right? So second part is having the answer as minus 25. Hope you got that. Let's move to the next question. Question number 3, section B. Now this again question is of 3 marks. You have to find out the integral minus 1 to 2 modulus of x cube minus x dx. Let's say this is equal to I. So I can be written as limit minus 1 to 2 x into, I'm taking x common, x square minus 1 dx, which is equal to minus 1 to 2 modulus of x. This can be written as x plus 1 into x minus 1 dx, right? So now here, if I talk about this, so here, x cube minus x is positive on minus 1 to 0, and x cube minus x is negative, less than equal to 0 on 0 to 1, and x cube minus x greater than equal to 0 from 1 and 2. Okay. See, now the limits are given from minus 1 to 2. So we have calculated like from minus 1 to 2. How is this equation behaving? Increasing, decreasing, like what? Okay, fine. So let's get back to our equation. This is equal to minus. Now I'll split it up. -1 to 0. From -1 to 0, this is positive. From 0 to 1, this is negative. And from 1 to 2, from 1 to 2, this is again positive, right? Now it's easy to find out the integral, very easy. I is equal to, this is equal to x cube, x raised to power 4 upon 4 minus x squared upon 2, limits -1 to 0, plus, I'll take this outside. Okay, I'll take the minus outside. So minus, this is x raised to power 4 upon 4 minus x square upon 2. Limits are from 0 to 1, plus x raised to power 4 upon 4 minus x square upon 2. Limits are from 1 to 2. Now you just have to fill in the values. This will be 0 minus, it is 1 upon 4 minus 1 upon 4, right? Plus, sorry, minus, this is 1 by 4 minus 1 by 2. Sorry, here is 1 by 2, not 1 by 4. Okay. Okay. And yeah. So this brackets -0, 0, plus this is 2 raised to power 4, which is 16 by 4 minus 4 upon 2 minus 1 by 4 minus 1 by 2. Correct? So this is equal to that's 1 by 4, 1 by 2 minus 1 by 4 minus 1 by 4 plus 1 by 2. This is 4, this is 2. That's 2 minus 1 by 4 plus 1 by 2. Okay, so now let's concatenate the terms. This is 1, 2, 3. So this is 3 by 2, 1, 2, 3 minus 3 by 4 plus 2. Okay. That is equal to 11 by 4. So this is the answer to the question. The integral value comes out to be 11 by 4. Hope you got that. Let's move to the next question, number 4. Here is, this question is carrying 4 marks. Now, using integration, you have to find out the area bounded by the curves x squared plus y squared is equal to 4. This is the equation of a circle. And x is equal to √3y. This is a linear equation. And x-axis lying in the first quadrant. Okay, let's make the figure first. So this is okay, this is 2. The radius is 2 because this is 2 square. The center is at origin. You have this equation x squared plus y squared is equal to 4, which is 2 square. So this circle is having the center as minus the coefficient of x. X is not present. So 0 minus the coefficient of y, which is again 0. And the radius is given by this 2. All right. Okay, next you have this line x is equal to √3y. This is a linear line. So this line will look something like this. So this is the line x is equal to √3 of y, right? Let's find out the point of intersection of these two first. So x square plus y square is equal to 4, and the line is x is equal to √3y. X square is equal to 3y square. So if I put in this one, this will be 3y square plus y square is equal to 4, or 4y square is equal to 4y will be equal to plus minus 1. So these are the 2 points of intersection. Since in the question we have to talk only for the first quadrant, so I will take only the positive value of y. Okay, and for that, if y is equal to 1, then x will be equal to √3. for y is equal to 1. So this is the point of intersection of this curve and this line. Hope you got that. Okay. Next thing is, and the x-axis lying in the first quadrant. So this is the x-axis. Basically, you have to find the area which is covered by this line, the curve, and the x-axis. So basically, you have to find out this shaded area. Okay. I hope you are clear till here. So what does this area now show you? Wait. Okay. So this area will be the area. If I'll mark it, let this point be O, this point be A, B, and C. So the required area is equal to area of triangle OCA plus area of curve ACB. Okay. This curve and this triangle, the area made by these two. Now, you know the area of the triangle is half into base into height. Area of triangle OCA is equal to half into OC into AC. But I don't know OC. What is OC? To find out the OC, I need the coordinates of C. And the coordinates of C will be given by C. The x coordinate was equal to root 3 and the y coordinate, of course, this is 0. Correct? So what is OC? From here, OC is equal to root 3 and AC is equal to, from here, AC is equal to 1. All right. So this is half into root 3 into 1, which is equal to root 3 by 2. That is equal to, let's say this is equation 1. Now you have to find out the area of the curve ABC, basically this area. Okay. So area of, I'll use integration to find the area of ABC. This is given by y into dx. I'll start from root 3 and go till 2. This is equal to y square by, not sorry, dx, right? So y was given by root of 4 minus x square dx from root 3 to 2. And this I'm again using, we have discussed this formula previously also. This is the formula integration of root of a square minus x square dx. This is equal to x square by 2 root of a square minus x square plus a square by 2 sine inverse x upon 2. I'm using the same formula over here. So this will be equal to x by 2 root of 4 minus x square plus 4 upon 2 sine inverse x by 2, limits from root 3 to 2. Okay. So, okay, this becomes 2 upon 2 root of 4 minus 4, which is 0, of course, plus 2 sine inverse 1 minus root 3 by 2, 4 minus 3 minus 2 sine inverse root 3 by 2. Now this is equal to 0. Sine inverse 1 is pi by 2 minus root 3 by 2 into 1 minus 2 sine inverse. What is the value of like sine inverse root 3 by 2? This is sine pi by 3. Yeah. Okay. So this becomes pi minus root 3 by 2. Sorry, this is pi by 3. And this is minus 2 pi by 3. That becomes pi by 3 minus root 3 by 2. This is the answer to the given question. Hope you have got that. So students, with that, we have completed the 4 questions for the set 2 paper, which were not included into your set 1 paper. For the set 1 paper, students, I already told you, you must watch our video for the set 1 paper. And I hope you're clear with this. Don't forget to visit our website, www.examsnet.com. This site is a great tool for you for practicing your entrance exam as well as the class 12 mathematics and other subjects question papers as well. Also download our app. The link is available in the description box. A very best of luck. Keep shining, keep rising high. Bye. Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, today we will be solving the class 12 CBSE Mathematics 2022 Term 2 All India Set 3 paper. This paper is in continuation with your Set 1 and Set 2 papers. I'll be discussing only the questions which are not there in Set 1 and Set 2. For seeing the questions for the Set 1 and Set 2, please refer to our previous videos. And students, you can do the same from our website www.examsnet.com. This site is also a great tool for you for practicing your CBSE Class 12 Mathematics, Physics, Chemistry, question papers. Also, you must download our app. The link is available in the description box for your better studies. So without wasting our time, let's start with today's video. Let's start with question number 1. This is from the section A, 2 marks question. You are given dy by dx. Let's write down the statement. You are given dy by dx is equal to 3 into e raised to power 2x plus 3 into e raised to power 4x whole divided by e raised to power x plus e raised to power minus x. Now I'll do one thing. I'll multiply the numerator and the denominator with e raised to power x. So I'll not touch the numerator one, but I'll take 3 into e raised to power 2x common from this factor. This is 1 plus e raised to power 2x into e raised to power x whole divided by, now this will be e raised to power 2x plus 1. See, over here, the numerator and the denominator, this factor will get cancelled and you will be left with the e raised to 3 into e raised to power 3x. This is equal to dy by dx, or dy is equal to 3 into e raised to power 3x dx. Let's integrate on both the sides. You will have a y is equal to 3 into e raised to power 3x upon 3 plus c. 3 will cancel and you will have e raised to power 3x plus c. Y is equal to e raised to power 3x plus c. This is the answer to the question. Hope you understood this. Let's move to the next question, number 2. Now this is from your section B. That means this question is a 3 marks question. Vector problem. You have to find the shortest distance between the two lines, this and this. You have to find the shortest distance. Let's write down the two lines first. This is, let's say this is R1. This is 3i, 5j, 7k plus lambda I minus 2j plus k, right? And the second line is given by R2. Let's say this is R2 minus I minus j minus k plus mu 7i minus 6j plus k. Okay, now comparing with R1 is equal to A1 plus lambda B1 and R2 A2 plus lambda B2. We get from here, what is the value of A1? This A1 is equal to 3i plus 5j plus 7k and B1 is equal to I minus 2j plus k. Similarly, A2 is this, B2 is 7i minus 6j plus k. Okay, and these are the vectors, right? A2 vector minus A1 vector. This will be minus 4i minus 6j minus 8k. And B1, the cross product of B1 and B2 vectors will be given by ijk 1 minus 2, 1, 7 minus 6 and 1. Let's find out further. This will be minus 2 plus 6, 1 minus 7, k into, this is minus 6 plus 14. Wait. This has got to be opposite. This is, wait, minus 14. Yeah. Okay. Minus 14 plus 6. Sorry, I got a bit confused. This is the same, minus 6 plus 14, because first of all, minus 6 minus of minus 14 will give you plus 14. Okay, I'll rewrite this. This will be equal to 4i plus 6j plus 8k. This is the value for the cross product of B1 and B2 vectors. Let's find out its magnitude now. So this is equal to root of 4 square plus 6 square plus 8 square, which is equal to 16 plus 36 plus 64. That is equal to root of 116. Now, A2 minus A1 vector, the dot product with B1 cross B2 vector, is equal to minus 4i minus 6j minus 8k dot 4i 6j plus 8k. This is equal to minus 4 into 4 minus 16 minus 36 minus 64, which is equal to minus 116. Okay, know one thing, right? That dot product of the unit vectors, two same unit vectors like this is equal to this is equal to this, and all are equal to 1. Now, the shortest distance between these lines is given by the formula. Shortest distance is given by A2 minus A1 dot product with B1 cross B2 whole divided by magnitude of B1 cross B2. Now this, the numerator was equal to minus 116 and the denominator was equal to root of 116, right? Under the mod, so this will be equal to 116 divided by root of 116, which is equal to root of 116 units. So this is the answer to the question. Root of 116 units. Hope you understood that. Let's move to the next question, number 3. Again, a 3 marks question. Now, this is an integral problem. Let's say this is equal to I is equal to limits minus pi by 2 to pi by 2 sine mod of x plus cos mod of x dx. Let's say this is the function fx. Let's say fx is equal to sine of mod x plus cos of mod x. See, if this is like fx is equal to this, then you know one thing. If we are dealing with the mod of x, then fx is equal to f of minus x. If this is so, then see one thing. This fx is an even function because fx is equal to f of minus x, right? And even function. If this is an even function, you can rewrite this statement. It was minus pi by 2 to pi by 2 sine mod of x cos mod of x dx. This can be written as, because this is an even function, so this can be written as 0 to pi by 2 sine x plus cos x dx. Now let's find the integral. So this will be 2. What is the integral of sine? It's minus cos. And what is the integral of cos? It is sine. The limits are 0 to pi by 2. Okay. So this is 2 into minus cos pi by 2 plus sine pi by 2 minus cos 0 minus of minus cos 0 plus sine 0. You know, cos pi by 2 is equal to 0. So this is 0 plus 1 minus of minus 1. This is plus 1 plus minus 0. That is equal to 4. So this is the answer to the question. The integral value for this particular question is equal to 4. Hope you understood that. Next is question number 4. Now this is a 4 marks question. It's a section C problem. You have to find the area of the region enclosed by this curve, this line, this and this line using integration. Hope you understood like what you need to find out, but I need to make the figure to understand what I need to find out. Let's make that figure. So here is your y-axis and this is your x-axis. Okay, you have to find the area of the region enclosed by these curves. Y square is equal to x. So this is the curve. Y square is equal to x. And x is equal to 1 by 4. So this is a straight line. X is equal to 1 by 4. This is the line x is equal to 1. And the line y is equal to 0 is nothing but your x-axis. Fine. So basically what you need to find out is the area, this. Area bounded by this curve, this line, these two lines, and the x-axis. This is what we need to find out in the question. Hope you got that. Okay. Okay, so let's start now. You simply this is a right parabola, right parabola. So this is y square is equal to x, or y will be given by root of x. Now let's find out the required area. Is given by. So now I'll start from 1 by 4 and go till 1. 1 by 4 till 1 y dx. Okay, so this simply will give me my area because this is the area between the parabola and the x-axis. Simple as that. Okay, and what was y equal to? It was equal to root of x dx from 1 by 4 to 1. This is equal to x raised to power 1 by 2 dx from 1 by 4 to 1. This is equal to x raised to power 1 by 2 plus 1, which is 3 by 2 divided by 3 by 2. Limits 1 by 4 to 1. So this will be equal to 2 by 3 will come outside. X raised to power 3 by 2, 1 by 4, or 2 by 3, 1 minus 1 by 4 raised to power 3 by 2. So 2 by 3, 1 minus, this can be written as 1 upon 2 raised to the power 2 into 3 by 2, right? I can write like this. 2 and 2 will cancel now. 2 by 3, 1 minus 1 upon 2 raised to power 3, that is 1 minus 1 by 8. 2 by 3 multiply 7 by 8. This is 7 by 12 square units. Actually, this is a pretty easy question. Once you make the figure, everything is done for you. No need to worry. This is a 4 marks question, and I think this is a very simple question for you. A very simple question for 4 marks. All right. So 7 by 12 is the answer to the question. 7 by 12 square units. So I think this is the last question for this set 3, class 12, CBSE Mathematics 22, term 2 on India paper. So students, don't forget to visit our website also, www.examsnet.com. This site, you can practice your class 12 question papers as well as your entrance exam question papers. Our app is also available. You can download the same for a better study material. So students, a very best of luck. Keep shining, keep rising high. That's all for this one. Bye.